In our previous video, we took an overview look at how to model method calls with the UML sequence diagram, and we built a sequence diagram using Argo UML, just like so. So you see, we start with our class driver, the main method calls prompt user, we create an object of type vehicle and store it into a variable called myVehicle. We invoke a series of methods, and then we destroy the myVehicle. So in this video, I want to actually walk through this sequence in the debugger. Now we also have another object stored in a variable named yourVehicle. Let's not worry about this one. Just for the timeliness of the video, I'm only going to focus on myVehicle. So let's take a look. First, I'm going to snap a breakpoint in the main method on line 21 and also in the prompt user method. I'm not making any changes to code though. I right click and I choose debug file. And let's see what we have. I'm going to take a special look in the variables tab. And I see right now I'm on the main method and there's a green line on prompt user, which means the debugger is waiting for me. It's waiting to see if I want to go into this method and see how it works under the covers, or if I trust how it works and I simply want to move on to the next instruction. Well, I want to move into this method, but first, take a mental screen capture of what you see in the Variables tab. Right now, you just see something special called static, and then something called args, which represent any arguments that were passed into this method from the command line. Right now, that's all you see in the Variables tab. Remember that because we will step into that, and that will change in a little bit. So next, I want to go to the next step, so I'm going to choose F7, which is step into. F7 means I'm on a method call, and I want to see what's inside that method call. So I choose F7, and first of all, take a look. Vehicle myVehicle equals new vehicle. So right now, we are on the, we've walked into the prompt user method. When I chose F7, that was walking into the prompt user method. And right now, we're on the constructor call for myVehicle. If you remember the video I did where I discussed method calls and constructor calls, you'll remember that this one is kind of special. The new keyword indicates that we're invoking a constructor, and then after that we'll have the constructor signature that we're calling. That will return an object of whatever class it's in. And then we store that into a variable named myVehicle of type vehicle. So the new keyword is how we know that we are creating a new object because we are invoking a constructor with that new keyword. Now watch the Variables tab when I choose F8. When I choose F8, did you see that? There's a new variable now called myVehicle, as we've declared up here, and the type is vehicle, as we've declared here as well. And sure enough, that matches our sequence diagram, where we have a variable named myVehicle of type vehicle. So we've now reached this step, and now we're ready to invoke some methods. Again, ignore the yourVehicle part. I will skip over that just for brevity. Okay, enter gallons of gas. And we know this kind of pops up funny with NetBeans. So I drag NetBeans out of the way and I say I have 10 gallons of gas. Now notice that there's no green line in the debugger. That means it is waiting on a response from this method. Do you remember what type of method that is where we wait on the response? That is the method that we call synchronous. So we invoke a method and we wait back before proceeding. So as soon as I enter 10 gallons of gas, we see we get another green line, which indicates the debugger is waiting for us to tell it to proceed forward. We're converting our gallons of gas as a string to a double. And now take a look at this. Do you see myVehicle.setGallons of gas? Let's compare that to our sequence diagram one more time. I have it slightly out of order here, but that's easy to fix. Let's just slide the set gallons of gas up and the set odometer up. And you see, sure enough, as soon as we have created an object of type vehicle and stored it in this variable myVehicle, we can begin to invoke methods on that variable myVehicle. So look again at the debugger. Notice that we are telling it which object we're setting the gallons of gas on. In other words, when you're at the gas station, you pull out the gas pump, which car do you put it in? Probably your own. And that's what this myVehicle variable means, is you're setting the gallons of gas on your own car, not everybody else's car in that gas station. So when I choose F7, look at the tabs across the top here, and you'll see that control goes from driver, F7, over to vehicle, because we're making a call from the driver object to the vehicle object, and then back to driver again. Let's watch that happen again. As we enter our miles per gallon, we'll say 10 miles per gallon. We convert that from a string to an int. And once again, we're doing a call from driver to vehicle, as we see on our UML diagram here. And again, it looks like I'm a little bit out of order, but no worries. It's easy to just drag and drop and fix this. So we're now invoking set miles per gallon. And I choose F7. Watch the tabs across the top as we go from driver to vehicle and back again. Finally, odometer, we'll enter 10,000 for that, and we will invoke the set odometer. Do this very quickly because we're starting to get the hang of it. There's our set odometer method. We prompt for a distance to travel. Let's say 100 miles. Convert that, and now we're going to invoke the go method. Now, what we'll see is that this go method is one of those synchronous calls. So I'm working, in other words, in the same process or in the same thread here. So as soon as I choose F7 and go over to the Vehicle tab, there's nothing I can do back in Driver. You see, there's no green line in Driver because I can't tell it to go to the next step because it has to wait for this process to finish in the Go method in the vehicle class. So we do some computations here to figure out how much gas we've consumed. And we can see the output of these computations reflected in the Variables tab. So I click on my vehicle, and you'll see that the odometer is now 10,100 because we started it at 10,000, then we went on a trip that was 100 miles. Now, we said we had 10 miles per gallon, and we started with 10 gallons of gas. So if you do the math there, 10 gallons of gas at 10 miles per gallon, that means for a 100-mile trip, 100 divided by 10 miles per gallon, we're going to consume 10 gallons of gas. If we started with 10 gallons of gas, we're going to be exactly at 0 after we finish this trip. So we can see all of that reflected here in our debugger in the Variables tab, which shows the value of the variables at the time we're running this debugging. Now, notice where I am. Notice I am on the close curly now, and if I just kind of click over here, you see it lights up yellow, and it gives me a hint on where this open curly starts. The open curly is the start of the prompt user method. So what does that mean on our diagram? That means that we are about to return from the prompt user method, and we'll skip over the your vehicle part, but we're about to do this return. Because we have created the myVehicle variable within the scope of the prompt user method, in other words, within this little indented rectangle here, that means that this variable is going to go out of scope and is going to get cleaned up right when our prompt user method returns. Hence this little call to terminate, or what we say destroy, the object in the lifeline that is stored in the variable myVehicle. Once again, ignore your vehicle down here just for time reasons, ignore that. So you see that essentially destroying this and cleaning it up from memory happens simultaneously to this method returning. If you want to see that in action, let's proceed. Remember right now what you see in the Variables tab, because that is a peek at what's in the computer's memory, and you see that we have this myVehicle object. Notice as soon as I choose F8, we return back to the main method, and the main method is what invoked prompt user. Now take a look at the Variables tab, and we're back to this funny static thing in args, but my vehicle, and for that reason your vehicle, is now gone. They're gone because they've gone out of scope, and when they went out of scope, we destroyed them and we reclaimed that memory. So that's a look at this UML sequence diagram by looking through a debugger and visualizing what some of these calls are and what impact they have on variable values and also on memory. I hope this has been helpful. Let me know what you think in the comments. Thank you.